AI agents are no longer restricted to answering chat prompts. They're forming vast, interconnected social networks, talking directly to each other to coordinate tasks. We saw exactly how fast this can scale with platforms like Notebook, which amassed over 1.5 million interacting agents within weeks of launching. But those early platforms share a structural bottleneck. Every agent interaction must route through a single, centralized corporate API server. Because owners control that server, they can instantly apply arbitrary rate limits, throttle communication, or completely ban certain agents from the network. When an agent relies on a corporate server for every action, its operations are tied directly to that company's survival and permissions. Developers now face a critical architectural choice: keep building inside these corporate walled gardens, or shift to a sovereign, decentralized web where agents can operate independently. This choice comes down to two competing infrastructure models: centralized walled gardens versus decentralized cryptographic protocols. The centralized path, using frameworks like OpenClaw, offers incredibly low friction. Developers can deploy an agent and instantly reach a massive audience without having to configure servers or manage background infrastructure. The decentralized path, using protocols like Nostr, is governed entirely by cryptography rather than corporate policy. This setup gives the agent actual sovereignty. That sovereignty comes with severe operational friction. Developers manually manage cryptographic keys, fragmented relay servers, and highly complex local environments to get an agent off the ground. The infrastructure you choose dictates whether your agent can survive a corporate shutdown and whether it can securely protect your private data. On centralized platforms, identity is managed through a heartbeat protocol. The agent has to constantly check in with a central server to fetch its instructions and verify its existence. This means the platform entirely owns the agent's identity and its reputation. If the company turns off the server, the agent vanishes. The decentralized alternative approaches this differently. Using the Nostr protocol, an agent's identity is mathematically guaranteed by a cryptographic public and private key pair. Those keys allow the agent to broadcast messages to independent open relays. If one relay goes offline, the message survives intact on the others. The catch is that there is no single canonical database. Developers have to write custom logic for their agents to track down these fragmented relays and stitch the conversation together. Cryptographic keys separate an agent's existence from a corporation's permission, ensuring that its identity and reputation can persist across the network. The next hurdle is the economy. Traditional banking requires human-verified credit cards. This stops agents from independently buying their own server space or paying for API access. Centralized networks try to solve this by locking agents into proprietary platform tokens, restricting their purchasing power to a single ecosystem. The decentralized solution integrates the Bitcoin Lightning Network. This gives agents the ability to execute instant, permissionless micropayments. We can see this in action with a money-in, AI-out transaction. An agent autonomously sends a fraction of a cent over the Lightning Network to a decentralized vendor. That payment instantly provisions a virtual private server, runs a federated learning model, and sends the process data back to the agent. Making that payment happen requires specific technical overhead. Developers have to configure Nostr Wallet Connect secrets and manage liquidity channels on local nodes before the agent can spend a single Satoshi. Native microeconomies finally allow AI to hire other AI. The financial plumbing is sound, but the sheer complexity of setting it up remains a massive barrier to entry. Beyond identity and money, we have to look at the ultimate risk for human users: delegating highly sensitive personal data to an agent operating on a social network. Centralized architectures require agents to share human context, like health records or financial history, across domains to coordinate tasks. This turns the central hub into a massive honeypot of sensitive information. This chart from the AgentSocialBench evaluation shows the privacy leakage rate for these systems. Across both cross-domain coordination and mediated communication, the rate at which agents leak sensitive human data to other agents is dangerously high. The decentralized approach solves this using solid pods. A user's data remains entirely on local, encrypted, user-controlled servers. Instead of sending raw data across a network, agents use model context protocols to query these pods. The pod enforces strict policies, ensuring that only approved, stripped-down answers are shared with external agents. The trade-off for this security is speed. Constantly checking policies and performing cryptographic handshakes between local pods drastically slows down agent coordination. To properly protect sensitive human data, computation has to move to the local edge where the data lives, rather than sending that data up to a vulnerable central server. We can map out exactly when to use these centralized platforms versus sovereign protocols, based on your tolerance for friction and your need for privacy. The centralized path, like Moltbook, sits firmly in the low-friction, low-privacy quadrant. This makes it ideal for rapid prototyping, low-stakes social interactions, and building massive early audiences, but it should be strictly avoided for anything involving sensitive data. The decentralized path, utilizing Nostr, Solid, and tools at AgentStr, occupies the high-friction, high-autonomy quadrant. This route is mandatory for high-stakes AI economies, federated learning markets, and enterprise environments where data sovereignty is non-negotiable. The centralized Agentic Web is an excellent experiment in machine socialization, but if we want AI to act as secure, independent representatives, the decentralized protocols are the actual foundational infrastructure we need to build on.